Hi, today I'm introducing a software that we built for Qualcomm Hackathon. This tool helps gather intelligent insights from UI UX interactions and helps developers improve the intuitiveness of UI. Introducing Chai, checking human actions intelligently. Before we dive deep in, let's meet the team. Hi, I'm Vivek, the captain, and we have Badri, Sanyog, Samyam, and Suvid on the team. We need a change in the way softwares are built and the way feedbacks are taken to improve on them. The current process of building intuitive applications is not streamlined and random, so we built Chai. Through our software, we go beyond guesswork and track gaze detection, facial expressions, keystrokes, mouse events, and action response times, giving us a comprehensive understanding of UI, providing us with better insights to building intuitive applications. As I mentioned earlier, our key features being extensive tracking and analysis of user behavior, more specifically, response time, keyboard and mouse inputs, gaze, and emotion analysis. So here is a high-level architecture of our software, which is divided into 4 steps. Before we get started, we first go about doing the camera calibration for accurate gaze estimation. Then we start recording the keyboard events, screen recording, mouse click events, and the webcam recording. Then we go about processing these recordings. So in the processing step, we do emotion analysis and gaze detection for each recorded frames. Finally, we show the insights such as gaze heat map, response times for each click action, a comparative analysis between ground truth and tester, and an emotion chart across frames. Let's go more detailed now. One of the challenges that we faced is synchronization between webcam and screen recording frames. This is because of the difference in frames per second between the screen and webcam recordings. To solve for this, we use the following pipeline. We record the frames along with timestamps, combine all the frames together, sort them based on timestamps, iterate over the combined times, and construct a group between the latest webcam and screen frames, and then we render it. In addition, we have built a robust user action tracking pipeline, where for every mouse event, we calculate frame number for the click event based on frames per second. Then we iterate from that frame number and compare against the click event frame and find the next non-similar frame, because mostly consecutive frames look similar. We use mean square error to check for the similarity. That is, we check for a spike in mean square error to find the changed frame. Once we get both these frames, we do image to text annotation and then we do a summarization. Here is the gaze detection pipeline that we used. So firstly, we calibrate the camera, do frame by frame prediction of pitch and yaw angles of the webcam recording frames, overlay the gaze on each frame, and additionally we generate a heat map for gaze on a 3x3 grid. In addition, we calculate response times for events using the following pipeline. This is similar to the action tracking pipeline, where we get the 2 frames and we try to extrapolate the response times from the frames per second. Finally, in the report, we get number of mouse events, max occurring emotion, user action report, and screen gaze summary to compare against the ground truth recording for insights into improving the intuitiveness of the application.
So this is the UI for our application. The idea is to compare a developer's actions with a tester's action and get an insight on the UI in terms of where the tester might have done things differently compared to the developer. First, we hit calibrate gaze on the UI and then hit start calibration. And this will help us calibrate the gaze detection model. What we need to do is we need to stare at this red dot on the middle of the screen, and as it moves across, we look at it and hit spacebar. Hit spacebar as it moves across. Once that is done, we hit start recording and then perform the action item on a website. For now, what I'm trying to do is turn off personalized ads on Amazon website. So I hit start recording. I give it a name. Let's name it demo recording for now. I hit save. And then recording starts. Now I go to the website and I perform this action. Here I am acting as the developer in that I know where certain buttons are and I know how to turn off personalized ads on the Amazon website. So I do that. My action item is now complete and then I hit stop recording. Now, once I hit stop recording, this will generate a few brief insights on my action, and then I hit process recording, and then this will run the gaze detection model, the emotion detection model, and generate a report on all my actions on the website. So once that is complete, we get a dashboard of all the insights. This would include an analysis of emotions over time, the probabilities of all the emotions. We can also compare it with the previous recording, and then we can hit this button right here to analyze the frame interactions. Once that is complete, we get a description of the page before and after a mouse click, and also a summary of the entire sequence of events. Once the frame interaction analysis is complete, we get a summary of the second video as well, and what we can do is we can compare it with a previous recording and then get a side-by-side comparison of both the videos. So for example, this would be the developer video and this is the tester video, and here we get a summary of the interactions in natural language, and this way we can compare what went wrong for the tester compared to the developer and then make changes in the UI accordingly. Yes, and we can also get analysis for both in the before and after format like we saw before, and a summary of both the videos. So this way we can compare between the two videos as well.
Future work. Coming to the future scope of the project, majorly we can improve by incorporating UI suggestions based on users' behavior and a live friction score dashboard, which will give us insight into the intuitiveness of the application in live. Thank you.